Hello, you are once again welcome to this course, and we are still looking at Unit 2, Subject Matter. We are going to consider the fifth session, which talks about selection of SHS core mathematics contents. Let's look at the objectives for the session. By the end of the session, you should be able to identify the major content areas of the SHS core mathematics syllabus and then justify the selection of specific topics in the SHS core mathematics syllabus. In our previous lesson, we talked about selection and sequencing of subject matter in JHS mathematics curriculum. At the senior high level, there are two kinds of mathematics that are being taught there. We have the core mathematics and elective mathematics. And we are going to look at the core aspects in this particular session. So the senior high school mathematics builds on JHS, or the knowledge that students have gathered at the JHS level, just like the JHS builds on the primary, the competencies that students have developed at the primary level. The same way, SHS mathematics builds on the knowledge and competencies developed at the JHS level. SHS students are expected to develop the required mathematical competencies to be able to use his or her knowledge in solving real-life problems and also be well equipped to enter into further study and associated vocations in mathematics. So you know that at this level, when students complete this level, some of them continue or further their education, others also enter the world of work. So at this level, they are supposed to develop the mathematical competence that will help them to achieve any of this. Let's look at the scope of the SHS core mathematics syllabus. 7 areas of content covered in the SHS core mathematics syllabus. And we are talking of the 2010 version. If you look at the 2010 version or 2012 version, we have 7 areas of content. And they are numbers and numeration, plane geometry, mensuration, algebra, statistics and probability, trigonometry, and of course vectors and transformation in plane. The last aspect is problem solving, and as we said under the JHS syllabus, it is not an area on its own, but it has been embedded in all the other areas. So the same way for the SHS syllabus, we have 7 areas, but problem solving and application can be found in all the 7 areas. Let's take them one by one and look at what each of them constitutes. The first one, numbers and numeration. What does it constitute? It talks about reading and writing numerals in base 2 through base 12 and the 4 basic operations on them. So 4 basic operations: addition, subtraction, multiplication, and division. So this talks about number or the numeration system, not only base 10, but from base 2 up to base 12. Then ratio and proportion and percentages are treated here. Fractions, integers, and rational and irrational numbers are here. Let's look at plane geometry. This talks about angles of a polygon, Pythagoras theorem and its application, circle theorem, including tangents, and so on. Then we talk of mensuration, which talks about perimeters and areas of plane shapes, surface areas and volumes of solid shapes, and then the Earth as a sphere. These are the 3 areas covered under mensuration. Then algebra. It talks about algebraic expressions, linear equations and inequalities, simultaneous linear equations, quadratic equations. These are the 4 areas covered under algebra. Then we look at statistics and probability. This one talks about collecting, organizing, representing, and interpreting data gathered from various sources. Then it talks about the fundamental concept of probability applicable in everyday life. And so basically, those are the 2 areas covered under statistics and probability. Then we have trigonometry. Areas covered: the trigonometric ratios, that's sine, cosine, tangent, and their reciprocals are all covered there. And their application to angles of elevation and depression, all covered. Drawing and interpreting of graphs of trigonometric functions, And then we look at vectors and transformation in a plane. And areas covered include vector representation, operations on vectors, equal and parallel vectors, magnitude of vectors and bearing, transformation, which deals with rigid motion, enlargement, and finally scale drawing and its application. So as we said, problem solving is not a topic on its own, but can be found in virtually all the topics. So almost all the topics, when you take them, you see problem solving and application in there. Let's look at the SHS topics in picture form. So we have this extract from the 2010 Core Mathematics syllabus, and it shows you the topics that are supposed to be treated, the contents at each level. So we have SHS 1, 13 topics or 13 units to be treated there. SHS 2, 12 units or 12 topics. SHS 3, we have 4 topics or units to be treated. So the rest of the SHS 1 and SHS 2 will be shown in the subsequent screens. So look at here we have it. So SHS 1, we have 13, SHS 2, 12, and then SHS 3, we have 4 topics to be treated. So you can pause the video and look at the topics one after the other, and then look at and try to classify them under the 7 areas that we have talked about. Let's look at justification of the selected topics. So topics are all of relative importance to the needs of the citizen. So every topic in the syllabus, we consider it to be useful to the student. So you might be teaching a topic at the SHS level, and the student will ask you, what am I going to use this for? This talks about the utility. Is it immediately or in future? So we shall look at them. Some topics are not to be utilized immediately, and they'll be applicable in the future. So every topic in the syllabus is important and has a form of utility and the requirements. So for example, set SHS 1, indices and algorithm, variation and quadratic functions, SHS 2, and logical reasoning, SHS 3 are seen by many to be difficult topics to teach and learn. So when you go to the schools, you realize that students find these concepts or topics very difficult to teach. So one of the factors that we talked about under selection is the difficult level, and it forms the way we sequence the topics to teach, and then the usefulness of the topic at the very time it is being studied or its application. So we see that the raw number system, algebraic expressions, relations and functions, and so on have become requirements for the SHS programs. They are requirements, therefore they are selected or they are part of the content to be learned at that level. We have come to the end of today's session, and as usual, I will leave you with some questions to look at. So I have 2 questions for you, as you can see on the screen. So you look at them, discuss them among yourselves. If you have any problem, don't hesitate to contact me. Until we meet for the last session of Unit 2,